Right, this is for Algebra 1. This section is really 3-3 in your textbook. I know we've already done 3-4 first, but I wanted to do those and then come back to this. Really, we're covering what we call function notation. Everything you're going to do has been the same with the slope-intercept form with the y, but now you're going to see function notation. So here, all you're going to be able to really be expected to do is I can plug values into an equation to evaluate a function. So I can plug values into an equation to evaluate a function. So that's what that's saying. Now what's function notation? I'll come back to this in a second. But think of this, 3 mathematical statements that are all the same, like y. So if we had y equals 9x plus 42, you've seen that. But now you're going to start seeing this f of x, which means that this f of x means it is a function of another variable. So what's the result? Once x is some number, what's your result going to be? Another letter you're going to see quite a bit, f is the main one, but a lot of times you're going to see g of x and also h of x. Now they choose these 3, f is going to be the main one because of the word function, but the g and h, they use that quite a bit too. So what is function notation? What is all of this about? Well, what a function notation is, it's a method of writing algebraic variables as a function of another variable, meaning this will change as a function. For every input, there's exactly one output. So this is what I want you to write up here. So function notation. Sorry guys, my finger's getting sore writing off so much today. Function notation is a method of writing algebraic variables. Oops. I can spell algebraic variables as functions, and that's the key thing, as functions of other variables. Meaning, when we have f of x equals 9x plus 42, what they're saying is when the input is 5, when this input, remember that's your input, when the input is 5, what's your output? Okay, so think of this as just like your y variable. So this is what it's going to look like. F of 5, now this does not mean multiplication. This does not mean multiplication. It means when x is 5, what does the output produce? So here's the equation, 9x plus 42. So if we replace x, 5 for x in both these situations, then that's 45 plus 42, which that's going to be 87. So when it does not mean multiplication, it means when the input is 5, what's the output? So when the input is 5, the output is going to be 87. Okay? So we're going to do some practice here with writing and seeing the function notation. So evaluate f of 0, and you read this as f as 0. So given the f of x, f of x equals 1/2 x plus 9. Well, if f is 0, what they're saying here, when x is 0, what is the outcome? What is the y value? So that's 0 plus 9. F of 0 equals 9. So when you see it like this, think of this as your x. That's your x. And this whole thing is your y. So this really could turn into an ordered pair, 0, 9. So f of 0 equals 9. That means your x value, and this is your output, your y value. So f of negative 2, well, given that f of x equals negative 14x minus 8, this means f of negative 2 equals negative 14 times negative 2 minus 8. Negative 14 times negative 2 is 28, and 28 minus 8 is 20. So your final answer always looks like the f of negative 2 equals 20. Then when the x equals negative 2, the outcome, this whole value, will equal 20. This actually turns into an ordered pair then, if needed, negative 2, 20. Okay? And that would be a point on the line. So here's some more. Okay, so f of 12, given that f of x equals negative 21x minus 12. So f of negative 12. Now write everything down, you guys, as you learn this. The more you get used to writing it down, the better you get at it. And it gives your brain time to slow down and process what it means. Okay, so now negative 21 times 12. So you're going to have f of negative 12 equals a negative times a negative. That's going to be a positive. And 21 times 12 is going to be 252 minus 12. And f of negative 12 equals 240. It does not mean multiplication. I'm going to keep saying that because some of you are going to think it's multiplication. It's just then when x is negative 12, the result, the outcome, the output is 220. So if you wanted to write it as an ordered pair, that would be the ordered pair. That's your x, that's your y. Don't forget about fractions. Now here's a g of x. Same thing, they just use a different letter. A lot of times they'll use this when you have multiple lines in one coordinate grid. So then you can keep, it's just naming the line another way. So you have g of 1/4 equals 4 times 1/4 plus 15. Well, 4 times 1/4, 4 of 4 is 1 plus 15. So g of 1/4 equals 16. The ordered pair would be 1/4 and 16. Okay. Now, here's what you're going to see in your work. Evaluate the function when x is negative 2, 0, and 5. That means you're going to have 3 different answers. Okay, so be careful when you see questions like this. You have 3 different problems that you're working with in one. So g of x equals, here's the equation, 12 minus 2x minus 5. So you're going to need to do this 3 different times. Okay, so I'm going to go ahead and separate this, probably in 3 columns. So my first one's negative 2. Well, I have g of negative 2, and I'm just going to plug in negative 2. Be careful here with that negative 2, negative 2. I'm going to plug that in to solve for when x is negative 2. So you have 12 plus 4 minus 5. So g of negative 2, 12 plus 4 is 16 minus 5. And so g of negative 2 equals 11. Okay? Then when x is 0. So when g is 0, not g is 0, excuse me, x is 0. G is 0. So that's going to be 12 minus, that's going to be 0 minus 5. So you're going to have 12 minus 5. And g of 0 equals 7. So we have g of negative 2 equals 11. G of 0 equals 7. And then g of 5. So when the x value is 5, what's your result? Oops, now I have a paper here. G of 5. Now this is 12 minus 10 minus 5. So g of 5, 12 minus 10 is 2 minus 5. That's going to be a negative 3. So all of these are ordered pairs. This is like negative 2, 11. This is 0, 7, and 5, negative 3. So if I would plot all those, I believe they should be in a straight line. So they would be a function. Here's another thing that you're going to see. Here's another thing that you're going to see. Find the value of x so that the function has the given value. So here's our function, h of x equals negative 7x. So what they're saying here, what this is saying, is they want to know what x equals in order to have an outcome of 63. So h of x equals 63. Well, if h of x equals 63, this equals 63. So h of x equals 63. So 63 equals a negative 7x. Well, what does x have to be to make this statement true? Of course, you're going to say, yes, divide. It's going to be a negative 9. So the x value, so what they're trying to find is, here's the equation, and the outcome, the output is 63. So what does the input have to be in order to have the outcome equal 63? Well, that has to be 9. Okay? So sometimes they'll rewrite this to say h of 9 equals 63. They're looking for what does that x value have to be in order to equal 63. Okay, so let's try this one. If we have f of x equals negative 4/5 x plus 7. And we're looking for what does x have to equal to make this total, this outcome, produce a negative 5. So what we're saying, f of x equals negative 5. So negative 5 equals a negative 4/5 x plus 7. Now, subtract 7. So this is just now solving for x. Negative 12 equals negative 4/5 x. Now, when you have a fraction, remember, get rid of this by multiplying by its reciprocal. So you're multiplying both sides by a negative 5/4. What that does is make that equal 1. So multiply this by a negative 5/4. I'm going to, excuse me, 5/4. I put 4/5. So I'm going to rewrite it down here. Negative 5/4 times 12 equals x. Now, 4 and 12, they cross reduce. So negative 5 times 3 is a negative 15. So the negative 15, f, when x is negative 15, it'll produce a solution, an output of negative 5 when it's applied to this equation. So what they're saying here is they're giving you now the output. You have to find the input. So that's what that type of question is saying. Okay, so that's function notation. You might seem a little iffy with it for a while. The more you work with it, you will see that a lot this year. The more you work with it, it'll become second nature before you know it. Okay, thank you.